Good morning, ladies and gentlemen, and welcome to today's webinar on DataCore SANsymphony-V Release 8.1, the one and only storage hypervisor. My name is Alexander Best, and I'm responsible for technical business development in EMEA at DataCore. We will have a Q&A session at the end of the presentation. Please use the question function to ask your questions. I will see it on the screen. I will repeat your question and hopefully try to give you an answer. I will let you know when we are there. So now enjoy the rest of the presentation. In the next 25 to 30 minutes, I will give you an overview about the latest development in SANsymphony-V Release 8.1. I will tell you how to identify opportunities and how we are different to other offerings on the market. DataCore was founded by people with a clear vision and true passion. In the last 13 years, we have pioneered and revolutionized a wide variety of storage-related areas. Today, DataCore delivers a mainstream solution, which is the first true storage hypervisor on the market. Compelling features and a mature software base form a reliable solution, which fit from small to medium business up to the enterprise. Virtualization today is everywhere. Virtualization is strategic. The most strategic asset of an enterprise is its data. And data is placed on storage. So why not virtualize the storage to get the most out of the most expensive and ever-growing asset? When we look at IT before virtualization, everything was hardware related, and migration from hardware to hardware was complex and bound a lot of resources every time a maintenance period ended. Scaling performance was complicated, and most of the time CPUs were idle for 90% of the time. Now, with virtualization, things get easy. New hardware rolls in, and the hypervisor decouples the hardware from the software. This allows IT administrators to move workloads from old to new systems on the fly. Performance demands are detected in real time, and adjustments are done all alone by the system. Sounds like heaven, doesn't it? But the big problem is how to get there. All these promises can come true if you manage to get yourself into a virtualized environment. Most virtualization projects still fail on the storage level, just because I/O patterns are so different in a shared workload environment compared to a distributed computing model. Hardware-based storage is hard to tune and to scale to meet this new type of performance requirement. Besides this, relying on a single shared storage backend magnifies storage-related outages and can cause major disruption, where before virtualization just a few systems did feel the impact. DataCore's approach of a storage hypervisor allows you to eliminate this type of unforeseen obstacles on the rocky path to virtualization. We can compensate performance bottlenecks, eliminate single point of failures and associated downtimes, deliver a rapid recovery mechanism in case of a failure, and finally allow to scale within budget by using commodity equipment. All achieved by the virtualization principle of decoupling the hardware. This allows you to leverage any existing and still suitable equipment instead of a rip and replace approach. And it gives you the chance to use standard components instead of expensive exotic devices. Repeat the lessons learned from server and desktop for your storage asset to get the most out of it, resulting in an end-to-end virtualized data center infrastructure. Let us look at the case study of an American police department. It was decided to virtualize the IT. After doing all the homework, it turned out that more than 90% of the budget will be inhaled by storage rip and replace to fulfill the virtualization requirements. With DataCore, it was possible to repurpose most of the storage equipment and so stay within the budget. By the way, a co-location data center was built and enough money was still left to do remote replication for the most critical applications. And here you can see how it is going to work. So first of all, you have a dedicated computing environment, dedicated servers, and when you choose to virtualize them, you get a lot of free servers because you can consolidate your workload, and all these spare servers can be repurposed. So for example, use 2 of them to build your DataCore servers. Then use your storage and attach some of your storage directly to these new DataCore servers, and out of a sudden this transforms into a virtual storage environment. You are free to add additional storage capacity on external components, and if you like to have remote disaster recovery capabilities, just take some of your servers and move them to a remote site, and also use one of the servers for a DataCore application and the other for a hypervisor application. So it could be very easy to go from a non-virtualized environment to an end-to-end virtualized environment. The DataCore SANsymphony-V storage hypervisor software delivers a full functional infrastructure-wide, mature and comprehensive feature set. We deliver sync and async mirroring, snapshot and continuous data protection, migration services, beside disk pooling and thin provisioning. Because of the limited time in this session, I will only concentrate on the most significant and latest additions to the feature set. In this case, we will talk about the auto-tiering feature. Other topics added in release 8.1 include integration in Microsoft Volume Shadow services, for example, Microsoft Data Protection Manager, redundant mirror paths over iSCSI links, an out-of-band initialization for asynchronous replication, which speeds up the process and bypasses slow WAN links, extended support for any type of SCSI 3-based clusters, which include Microsoft Cluster and, for example, Oracle Real Application Cluster, a comprehensive PowerShell scripting API, and finally improvements to the license and activation management. Okay, let's take a closer look at the auto-tiering feature. Traditionally, storage tiers were based on storage pools, and the LUN was carved out of a storage pool. Tiering is possible with DataCore solutions since day one, but tiering was done on a LUN level. To move data from tier to tier, the whole LUN needed to be moved. This concept was fine prior to server and desktop virtualization because servers had dedicated workloads and required relatively static performance within a LUN set. In today's highly virtualized server infrastructures, a LUN has to deal with various data types and also widespread performance requirements on the sub-LUN level. To move a whole LUN from tier to tier is no longer suitable because for moving only a few hot blocks to a faster tier, the whole bunch of less active or idle blocks will also occupy space in fast tier. This is not efficient. Auto-tiering solves this problem by identifying individual hot areas within a LUN and moving the hot areas fully automatic to a faster tier, while less active blocks stay where they are and idle blocks eventually get moved out to slower tiers. You're able to specify the scope of data movement by assigning one of 5 storage profiles to each individual LUN. The storage profile defines the number of tiers a LUN can distribute the blocks and how they get distributed compared to other LUNs with different profile settings in the same pool. Each data pool has its individual tiering model, and so LUNs can still be moved from pool to adopt different tiering models. Auto-tiering usually causes a lot of questions. On the next 3 slides, I have compiled the most common questions and answers. If additional questions pop up in your mind, you have the chance to ask them when we reach the 3rd slide. Okay, let us start now. How many storage tiers are supported within a pool? We support up to 15, but usually people think about 3 tiers to just compensate SAS, SATA, and SSD. In this case, SSD would be the fastest tier. How frequently will the algorithm migrate disk chunks? An individual disk chunk will not be moved more often than once in about 2 or 3 hours, but the whole disk is movable, and so in the whole block architecture will also react fast on individual changes. But this limited movement for an individual block will prevent disk thrashing on bursts. How are tier levels assigned to disks in the pool? IT assigns the disk tiers according to the price, performance, and capacity given by the individual device. So it's very easy. You just decide if a SAS will be tier 2, if a SSD will be tier 1, or if a SATA will be tier 3. Can the tier level of a disk in the pool be changed? Yes, anytime, non-disruptively while it's up and running. Can the storage profile of a virtual disk be changed? Yes, anytime, non-disruptively while you're using it. Does the auto-tiering replace the fixed assignment of a virtual disk to a tier? No, not necessarily. Auto-tiering complements the fixed disk assignment we had previously. You can also override the automatic migration by pinning a virtual disk to a specific tier. So effectively let the data just sit in a specific disk class, while other disks in the same pool are allowed to move up and down. Do I have to have identical tiering on both sides of a mirror? No. The storage profiles are dynamic and storage server centric, so you can have 3 tiers on one side of the mirror and 5 tiers on the other side of the mirror, if this makes sense. Is tiering cache aware? Yes. It's acting in a way that the cache access also influences movement of the data among tiers. What happens when a tier fills up? So if a tier is full, the system first tries to fit the data in the next best slower tier, or next best lower tier. If all lower tiers are filled up, the system tries to fit the data in the next higher tier. And by nature, if all tiers are full, the pool is full, and I think you have a different problem. How does data move actually? Data only moves up on heat up, and it only moves up one tier. If a data chunk cools down, it only gets moved downwards a tier when a hotter chunk requires space. So this means whenever there is enough space in your higher tiering architecture, it stays up there and will deliver full performance as long as possible. How does the data heat up or cool down? Data temperature is determined by dynamically comparing the individual data access rates to the average data access rate within a given tier class. So we calculate a global temperature of your pool, then a data access temperature per tier class, and then the individual block temperature based on the individual block access. And all this makes up a model where a block may bubble up on heat up and maybe push down on cool down. Is read and write treated the same way? No, read and write does influence the temperature model differently. How do I turn off tiering? Just set a pool to have only one tier level, and so effectively there is no difference in the tiering affinities, and it's all now stable within one class. Final question, can I schedule tiering operations to fit specific requirements? Yes, this is achieved by the built-in task engine in conjunction with the DataCore PowerShell commandlets. And you can, for example, say if there is an application that only requires once a month high performance and the rest of the month it's idle, the data will be usually on a low performance profile that we call archive, and the schedule task can push this data up to a critical class just 1 or 2 days prior to the application batch run. You leave it there for the batch run, and after the batch run is finished, the task then moves the data down back to the archive level, and so the data is always at the spot where you expect it. So now it's open question area. Feel free to ask if you have any questions to these actual topics. And how will the migration process most likely look like from an existing customer with implemented NMV pools to auto-tiering configuration? That's very easy. First of all, when you migrate your non-auto-tiering architecture to the auto-tiering system, the auto-tiering will just have one tier assigned, one tier class assigned. And then you are able to increase the number of tier levels per pool and eventually add devices to reflect the faster or slower tier classes. And if you don't want to move to an auto-tiering architecture, just leave it at one tier level per pool, and so you're fine. Next question. When data are moved to different tier, an entire SAU is moved. Yes, we always move on the SAU level. So depending on the SAU size you use within your pools, this is the granularity in which we move data up or down. Next question. Can you disable caching on a tier? No, you can only disable caching on a virtual disk basis, but you can't disable caching on a specific tier. Next question. What's about the estimated mean time between failure of SSDs? In the case they build the fastest tier, it sounds like due to auto-tiering they will die faster as usual. Not necessarily, but this is just because data only eventually will be put on the fastest tier and is not permanently there if other data is required to be on different locations. What we see in practice is that SSDs tend to live longer with the DataCore architecture because we reduce the number of override activity on the individual SSD, because our write coalescing is already compensating small block updates, which causes less wear off on the SSD. But definitely the SSD has a limited lifetime and you have to look at it. But I think we don't reduce the MTBF. We may be able to increase the MTBF, but in worst case just use the MTBF that is documented by the vendor of the SSD. Okay, next question. How big is a chunk that is used for identifying the hot areas for auto-tiering? It's like a SAU? Yes, that's the thing. We monitor the access to a given SAU. So if you have a high access rate within a, for example, 128 megabyte boundary, then this is what makes a SAU heat up or cool down. Next question. What about the SAU sizes when using auto-tiering? Yeah, it's the same as usual. The bigger the SAU size, the more efficient the system works in terms of operation, in terms of performance. The smaller the SAU size, the more efficient it may be because of smaller granularity. So we still recommend to stick with the 128 megabyte or larger SAU. The smaller you create the SAU, the bigger the overhead gets on moving, allocating SAUs. So only use smaller SAUs if you are specifically informed by a tech bulletin or whatever we have that may tell you using something smaller than 128 megabytes. Next question. I got a question regarding heating up. If a database operation running once a month for some hours, does this cause tier change? How long is the regular profiling time? That's a good question. I can't tell you because this is highly dynamic. It may be that it is able to move the data blocks within a few minutes to the higher tier. But depending on how idle the blocks have been in the meanwhile, it may take longer. So if you want to have a guaranteed response time for an application at a specific time in the month, and most time the data is idle, then use a profile change instead of just waiting for the mechanism to start. Profile change does not necessarily mean you have to put all the data in the highest possible tier. You can also say the data is low or archive mode in normal, what means you're at the lowest possible tier. And then you decide, okay, I will move it now to a high profile, not a critical one. So you will be able to place the data in tier 1 and 2, or in the 2 higher tier classes, and not necessarily block all space in the top level tier class. So you have more than just a black and white decision here on doing this. So we still have some kind of learning curve how fast the system maybe react, but this depends also on the access profile your application has. And since we have the flexibility to use scheduled operations and you can run it on demand, feel free to use it to your advantage, depending on what you're going to do. Next question. If I break a mirror on the first VDisk, if I break a mirror and the first VDisk was on side 2, the VDisk is now served from side 1. If I set up mirror again to side 2, will then side 1 become the preferred side of the VDisk? Yes. Always the side that remains online will be the preferred one, and the side you add to the mirror will be the non-preferred one. Next question. Can tiering be disabled on a schedule so that backups don't affect the temperature of data being backed up? No, this is not possible, but usually a backup is a sequential data stream touching a SAU only on a very low frequency. So it is not going to heat up data when you just go sequential through a disk for doing a backup. So this is what we also spoke about, the thrashing. So this is what we treat a short burst. And when you just run through the disk once, you're not heating up the data. So this is working fine. Next question. Any recommendations about SAU sizes for best performing auto tiering? Yeah, 128 megabyte or higher. Okay. Next question. But data will be placed on the fastest tier if possible? Yes. Whenever the faster tier is available, we will put it on the fastest tier. But only if you allow your disk to be in the fastest tier. If you say your disk is on a low profile, for example, you're not allowed to place the data on the fastest tier. It's just on the relatively fastest tier, will be middle tier or lower, but never on the higher. Just depends on what you're going to do. Next question. Have you some tests of Ramzan hardware in version 8? We are just awaiting a couple of Ramzan devices in our Munich lab to do some tests. Currently we have done tests with the Fusion IO hardware. We have done tests with the Xiotech hybrid eyes. And as soon as the hardware arrives in Munich, we are going to test as well, and we may be able to share results. Next question. Is it planned to measure the performance of a physical disk to automate the tier settings? No, this is not planned because tier levels may be more than just performance. It could be also a cost aspect, and so it's not suitable to base it on a measuring mechanism. Next question. Backup application produce high I/O load. Is it possible to disable auto tiering? Yeah, I think I answered this already. Next question. Reclaim unused space still works at SAU level? Yes, it does still work at SAU level. Next question. Will there any monitoring solution how big my hot data per hour is? This will be very helpful for sizing the different tier classes. This is a hot topic. Currently, there is no technical solution for measuring performance on a sub-LUN level. We're just exploring if there is a way to do it before implementing DataCore. But currently, there is no technology on the market allowing this. Whenever we have a DataCore solution in place, you can see this, and we can use the heat maps to give you a rough picture of where your requirements will be. But unfortunately, without the DataCore in place, there is currently no technology for doing individual block-by-block sizing. We have recommendations to have about 5 to 10% on SSD, about 30% on fast spinning disks, let's say SAS, and all the rest on SATA. What is the best effort approach? What we know from the real-world responses we have. Next question. Will shutting down a VM force the data migration of that virtual machine data on a lower, colder tier level? No, not necessarily, but you can script it. Let's say you have a script that shuts down a VM. Then you can identify the disk to be on a lower tier, but this is then only working on a full LUN level. The data may be moved down to a lower tier if it gets idle. So this means if the blocks cool down and there is a requirement for other blocks to populate the faster tier, then eventually blocks gets pushed out to lower performing tier classes. But as long as there is capacity available, we don't touch it to be ready whenever you need the performance. Next question about SANsymphony Traveler. Will they get CDP for free? We will have an appropriate offering whenever you migrate a Traveler to SANsymphony-V that there is an equivalent CDP included in the solution. But anyway, when you go to migrate a SANsymphony 7 to SANsymphony-V, you will end up in a VL4, VL5 class, which includes CDP 48 hours anyway. Final question, where can I download the Fusion.io tests? Drop me an email. I will give you some information about what we tested with the Fusion.io. It's just because there are different questions to it, and we did some tests on the overall performance. If you have some specific things you like to know, let us get this done on the individual email base. Okay, so I think all questions are answered. I hope no one is left over here. Good, so to be honest, we are running short on time. I have only 2 minutes left. Let me see that we cover everything that we are going to look for. So the other important enhancements that are included in SANsymphony V version 8.1 are VSS. I already spoke about this. This allows you to trigger consistent snapshots for any VSS aware application and integrates into the data protection manager from Microsoft System Center. Then we have this extended SCSI 3 reservation model, what allows you to have now up to 16 nodes in a cluster configuration accessing the same shared disk. The redundant mirror path over iSCSI now makes the feature set identical on Fiber Channel and iSCSI, so that you have the full and same redundancy level with the pure iSCSI implementation at the same function level that you had with Fiber Channel beforehand. Then we have the out-of-band initialization for the asynchronous replication, and this gives you the opportunity to initialize the data to a removable media, take the media, ship it across to your destination, feed the data in, and then let the stream resume while you do it in an offline init mode. And then not to forget the PowerShell API, which gives you a lot of opportunities to do all what you have seen in the GUI, also now from a command line, to automate certain tasks, to integrate with any given application, and to integrate with third-party offerings, hypervisor backup solutions, disaster recovery solution, whatever you think of. So in summary, we deliver a sophisticated, easy-to-use solution, and this solution empowers you to present fast and highly available storage with a 3-click approach. First click, right-click on the server. Second click, quick serve and adjust size. And third click, click on the serve. That's it. The generated virtual disk will automatically have the highest possible redundancy configured, is placed on the least used pools, is accessed via the least used path, and has tiering profile to span all possible tiers. And if you don't like it, you are able to modify everything for this disk later on the fly to make it fit your needs. In combination with Microsoft's failover cluster feature, Hyper-V and the file service role, DataCore transforms also into a unified block and file solution on the same box. So we are delivering true unified storage. So in fact, we address the three current major tasks for infrastructure-wide storage administration. First of all, we have capacity management. We address this with thin provisioning and the tiering within the pooling. We address performance management through our adaptive caching, the load balancing across multiple paths and multiple disks within the auto-tiering architecture, and use our built-in best practices to use auto-tuning and pathing wherever it's possible. And finally, the data protection management, which delivers your data protection at 3 levels. So first of all, you have a data layer protection with continuous data protection, what gives you a protection against any logical failures. Then we have the local failure protection with the synchronous mirroring, protecting you against disk outages on a single site. And we have the remote disaster protection that gives you a protection against any kind of global site outage where you can have a disaster site taking over and continue working. And this all works not only for legacy environments or server virtualization environments, this also works for VDI at the same level. And as you can see, we already got some very interesting feedback about what we are doing to VDI, and watch out what will be there on the web in the future. So finally, common sense tells you when you virtualize your servers and desktops, you should better virtualize your storage too. So use our storage hypervisor to do what you have to do and get the end-to-end virtualization done. Okay, thank you for taking your time. Goodbye, and thank you for joining me.